things were thought to happen. A recent discovery, however, has shown that this is not always the case, and has forced a rethink of what happens to everything in a solar system when the host star has run out of fuel. After the supernova stage, a star collapses back in on itself to create a super-dense white dwarf. These are littered throughout our galaxy and are often studied, but one in particular returns some interesting results. Lying around 2,000 light-years away from Earth, researchers measured emissions of hydrogen, sulfur, and oxygen that were coming from it, which is quite unusual, so they looked closer. They found the elements were emanating from a ring of gas around the star, which it turned out was trailing a Neptune-like planet that was orbiting it every 10 days. It's something that had never been seen before and is yet to be seen anywhere either. Quite how the planet managed to survive so close to a star that was once supernova is not entirely clear, but it proves that the assumptions that have been made about the evolution of star systems need to be revisited. Number 3. Hyperion. Saturn has 83 known moons that aren't within its rings, and each one of them has its own unique properties. The strangest of them all, though, is Hyperion, which was first discovered in 1848. It's an irregular shape, has an unpredictable rotation, and is covered in craters, and it was the first non-spherical moon to ever be found. The current theory of why Hyperion is such a strange shape that it is was once a part of a much bigger moon that was destroyed in a collision, and what we see as Hyperion is all that remains. This large proto-Hyperion could have been up to 620 miles in diameter, and the release of all this material would almost certainly have had an effect on other nearby moons, and potentially added to Saturn's rings. A further mystery are the craters on its surface, which are so deep that probes have been unable to image what's at the bottom of them. It's often referred to as a sponge moon because of the way it looks. Recent estimates have suggested that as much as 40% of the moon is actually empty space. This has led to the strange wobble in its orbit, which doesn't appear to follow a set pattern like most other objects do. It means that it exerts a weaker gravitational force than would be expected for something its size. Thought to be made purely of rock and ice, the Cassini probe flew quite close to it in 2005, which is why there are such good images of the moon. This also found a further mystery of Hyperion. It has a slight electrical charge to it, and right now, no one knows why. Number 2. Solar terminator events. The more we learn about the sun, the more fascinating it becomes. Far from being a flaming ball of gas in the sky, it's a complex network of magnetic fields, plasma fountains, and strange blobs of unexplained matter that are formed at its surface. But recently, researchers have discovered some of the most powerful events ever measured, known as solar terminator events. You probably know that the sun goes through a cycle of peaks and troughs in terms of activity every 11 years or so. There are times when it's far more active than others. Towards the end of the cycle, there are fewer sunspots and emissions, so scientists were trying to find out what happens to kickstart the process all over again. They found that towards the end of the cycle, weakened magnetic fields collide along the sun's equator, and these trigger huge tsunamis of plasma that ripple across its surface for weeks at a time. In the wake of these storms, which are the most powerful to take place in the solar system, giant spots begin to form on the sun, and the cycle starts again. Quite how these terminator events are triggered is not known, though, and it's not entirely clear if this happens at the end of every cycle or whether it's less frequent than that. One thing's for sure, and that's that there's still a lot more to learn about the star that we rely on so much, and what we find out could have profound consequences for us as a species. Number 1. Borisov. While Oumuamua was the first object to have been detected that originated from outside our solar system, it is now long past us and it's impossible to study it anymore. That's not a problem though, because what they learned about it, researchers have already managed to locate another object that also came from somewhere else, a comet called Borisov that had a tail more than 100,000 miles long. The first close-up image of it was captured in November of 2019, where it was seen surrounded by a bright white glow. The reason why it was certain that Borisov isn't from our solar system is because its trajectory and incredible speed. It was moving so fast that it was only spotted several weeks before it passed Earth, and by now it's well on its way to leaving our solar system altogether. That's an impressive feat in itself, considering it's taken Voyager probes more than 40 years to accomplish the same thing. As for its origins, this still remains unclear. The region between solar systems is virtually empty, with no way for new rocks to be formed, so it's unlikely that it came from a nearby star. But with the nearest being more than 4 light-years away from us, it's been a long journey for it to get here.